Before students can learn any exciting new skill, they have to learn the basics. Let's talk about how this is done in many classrooms through direct instruction. This method of teaching shows students how to do something, not just explaining it, as is done in presentation style teaching. Direct instruction provides the mechanics before the magic, so to speak, and is particularly useful in skill heavy, performance based subjects such as math and science. Direct instruction is backed by several psychological theories, the first of which is behaviorism. This theory tells us that learning is shaped through reinforcement, and that direct instruction works best when students are given clear objectives, then reinforced repeatedly. Next, social cognitive theory tells us that humans learn through observing and modeling the actions of others. This kind of learning involves paying attention, retaining the information, and reproducing what you've observed. Teachers can maximize the effectiveness of this by keeping modeling simple and interesting to students. Research into teacher effectiveness has found that direct instruction leads to higher engagement, more time on task, and higher student achievement. Of course, more organized classrooms lead to better learning outcomes, so it's important for teachers to plan ahead prior to direct instruction. It is beneficial to write skill focused objectives that are observable and measurable, such as the student will be able to solve for x in the equation. That way, success can be easily determined. Some teachers find it useful to complete a task analysis to break new skills down prior to teaching them. This involves 4 steps. 1. Identify what an expert does. 2. Break the skill down into smaller subskills. 3. Put the subskills in a logical order. And 4. Plan how to teach each part. It is worth noting that knowing all parts of a skill does not equate to being able to perform the whole skill. This is where practice comes in. In any good direct instructional lesson, there should be 5 phases. The first phase is establishing a set. In this phase, you will get students ready for the lesson by explaining why it matters, giving an overview of what they will learn, and activating prior knowledge related to the lesson. The second phase is the actual demonstration, in which you should show the skill clearly, thinking aloud if possible. This step requires teacher mastery of the skill and should be rehearsed beforehand. Next comes guided practice, in which students try out the new skill with support from their teacher. These should begin in short, meaningful chunks to avoid overload. The fourth step is feedback. This is critical, as practice without feedback is almost useless. Feedback should be immediate, specific, and focused on what the students did rather than why the teacher perceives it was done. It can be beneficial to show correct performance when giving feedback, as this can help the student learn self-assessment. The fifth and final step is extended practice. This can be done via seat work in class or homework if students are being supported at home. This extended practice should be engaging and be an extension of learning rather than an introduction to any new material. For extended practice in class, be sure to establish clear systems for what students should do if they get stuck, as well as what to do if they finish early. Let's take a look back at the demonstration phase. As with any lesson, differentiation is important. Lower achieving students may benefit from key ideas being projected or written on the board to help them follow along. These same students may also benefit from extra encouragement during their practice. Higher achieving students may be positively challenged by being allowed to figure things out on their own while you support others. This type of productive struggle can foster independence and critical thinking in advanced students. Another element to consider is classroom management. Studies have shown that organized classrooms result in more learning time, so it's crucial that misbehaviors be addressed quickly to get learning back on track. So let's say you have completed all the phases of a successful direct instruction lesson. Your final step is to assess student learning. For these types of lessons, the best fit is often performance-based assessments, in which students must do a skill, not just talk about it. Some teachers find these types of assessments difficult to design and time-consuming, but if you can manage to do it, they are still the most effective way to assess skill mastery. Let's hear from an educator with a proven track record of helping students master skills through direct instruction.
All right, so tell me what grades and subjects you've taught and for how long.
I teach 6th grade math, and I have taught 6th grade math for 18 years.
Have you always been at this school?
I've always been at Severe. Yes.
That's
And I actually came in, and my first year I was part-time because it was the recession, and so they actually were cutting teachers, and there weren't a lot of open positions, and so what was left over when they were hiring was only a part-time position. So I kind of like squeezed in.
So this lesson is going to be about like direct instruction on like teaching skills, and you teach math, so there's a lot of skills involved in that. Can you talk about how you teach it in a way that's going to help them learn the skill?
I am very old school in the fact that I don't give a lot of fill in the blank notes. I'm very, you write your notes. We figure out, you know, how when I look at my notes, what why does a vocabulary word stand out when I'm doing an example of a problem? And so that repetitiveness throughout the year, I feel like one, when they write it down, me saying it over and over, I really am a true believer that they need to write it down. There is something about writing it, hearing me say it, them reading it back to themselves. Like I do feel like that there is a learning component with that. So those note taking skills, those writing skills, those organizing skills, like all of those are underlying in those math lessons. Like those things that you wouldn't think are important, but if kids didn't do them, they wouldn't have them. Like when they went to high school, and then
we're all English teachers a little bit.
yeah. Yes, so true. Yes. And then the elementary teacher in me, because that's my background, is to really focus on that organization. I mean, like, because those sixth grade boys are a hot mess. I mean, just like their book bags are an open hole that never ends. Yeah.
So then when it comes time to test if they've learned the skill or not, do you make your own tests or do you use the curriculum ones?
I don't use either.
Oh, okay. Tell me about how you test them.
I test in Master Connect. Because which is the I think some people are trying to go away from it, but it is most like a state test. And so I want them to, if they take these open-ended tests all year long, when they get to, I mean, their brains are not mature enough to truly understand the magnitude of the test that they're taking. And so I feel like they get a little bit of practice with not just clicking answers, which is important for me. And then the vocabulary that's in them and the way the problems are written, I think is important, because it's important to learn how to take a test as much as it is to learn
It's another skill.
The skills. Yes, yes. And so I strategically do use the Mastery Connect tests. Now they have to show their work. I print them out even though they're on the computer before they are allowed to answer in the computer. We do it on paper. Oh, okay. And then at the halfway mark, so when semester 2 starts, all of our operational skills are done. And so we switch to calculator skills. So then when we get there, we have to learn how to use a calculator and what the calculator actually does, which is a skill all in itself. But once they realize, oh, if I input this into the calculator correctly, the calculator will do the order of operations for me. And so we talk about why it's important to know with our rewrite, substitute, solve. Like, it's not just when you're solving the problem, but if you want the calculator to solve the problem, you've also got to know how to do that. Yeah. We talk about what the different buttons on the calculators are. And so it's kind of crazy, because then they all want to use the calculator, which, listen, you got to know how to use it right.
But at least they tried it without the calculator the first half, so they know the skills.
Yep. So the first half is, our standards are the operational skills. Like, you have to know how to add, subtract, multiply, divide fractions. You have to know how to do all of those operations with decimals. But then when we're in statistics and ratios and all of that, the operations are not what we're looking at. We're looking at, can you do this now that you know the operations, which is why they allow the calculator to do it.